All right, let's talk about numbers, but not just any numbers. We're talking about the secret agents of the math world, the mysterious building blocks of, well, everything. Prime numbers. For thousands of years, they fascinated mathematicians, and today, they're the invisible engine quietly running our entire digital world. So, let me ask you a question. What on earth could possibly connect some Greek scholar from over 2,000 years ago with the password you probably just used this morning? The answer, believe it or not, is a very special kind of number. And by the end of this, you're going to see exactly how.
Okay, so to crack this mystery, we have to start at the very beginning. We need to get to know the star of our show, the prime number. You know, the definition of a prime number is actually beautifully simple. A prime is any number that has exactly two factors, and factors are just the numbers you multiply to get another number. For a prime, it's always just 1 and itself. That's it. That's the whole rule. Think of the number 7. The only whole numbers you can multiply to get it are 1 and 7. This special exclusive club is what makes them primes.
This really splits all numbers into two main camps. In one corner, you have the primes, 2, 3, 5, 7. They're like the fundamental atoms of math. You can't break them down any further. And in the other corner, you have composite numbers. Take 10, for example. You can break that down into 2 times 5. Pretty much every whole number is either a prime itself or is built by multiplying a unique set of primes together. They're like the Lego bricks for all other numbers.
But of course, there's always a weird one, isn't there? The number 1. See, it only has one factor, itself. And remember the rule for primes? You need exactly 2 different factors. So 1 doesn't make the cut. It's not prime, and it's not composite. It's just 1, kind of in a class all by itself.
So, if primes are so important, how do we actually find them? Well, for that, we're going to have to jump in a time machine. Let's head way back, over 2,000 years ago, to ancient Greece, to meet a brilliant mathematician named Eratosthenes. And this was his genius invention, the sieve of Eratosthenes. Now I know, it just looks like a grid of numbers, right? But don't let that fool you. This is an incredibly powerful, ancient machine for finding primes. Think of it like you're panning for gold. You're just washing away all the composite numbers to find the little golden nuggets, the primes, left behind.
So check out how it works. It's so elegant. First, we get rid of 1 because we know it's not prime. Boom, gone. Then we circle the first prime, 2, and we go through and knock out all of its multiples, 4, 6, 8, all the way down the line. What's the next number that's still standing? 3. So we circle it and do the same thing. Cross out all of its multiples, 6, 9, 12. You just keep repeating that process.
And just like that, once you've gone through the whole grid, what's left? The numbers that are circled. Bam! Those are your prime numbers. It is such a simple, beautiful method for revealing this deep, hidden structure in the number system.
Now the sieve is fantastic for finding primes up to 100, maybe 1,000. But what if you wanted to find a prime number that was, say, 20 million digits long? Yeah, you're going to need something a little more powerful than a piece of paper. So let's jump forward to today, where the hunt for primes has gone completely digital. Whoa, just look at this graph. Until computers really got powerful, the largest known prime had fewer than 1,000 digits. But then, look what happens. The curve just goes vertical. We are not talking about thousands of digits anymore. We're talking about millions, tens of millions. The scale of this modern hunt is just mind-blowing. And you know what's really cool? This isn't just happening in some secret lab at the supercomputer. Nope. There are these huge public projects, like the Great Internet Mersenne Prime Search, that literally link together thousands of regular home computers, maybe even yours, into one giant prime hunting network. It's a massive worldwide team effort that anyone can join. Okay, so this all begs the question, why? Why is there this global obsession with finding bigger and bigger prime numbers? Well, this is where it all comes full circle. Remember our question from the beginning about ancient Greece and your online security? This is the answer. So get this. All of the encryption that protects your digital life, your bank info, your emails, your private messages, it's all built on a very clever trick with prime numbers. A computer can take 2 ridiculously huge prime numbers and multiply them together in a fraction of a second. Easy. That new, even more gigantic number becomes a sort of public lock. But, and this is the crucial part, trying to take that giant number and work backwards to find the 2 original primes, it's practically impossible. Even for the fastest supercomputers, it could take longer than the age of the universe. Those 2 original primes, that's your private key. The entire security of the modern internet rests on that one simple fact. Multiplying is easy, but factoring is brutally hard. So primes are ancient, they're modern, they protect all our data. But you know what? The story is far from over. In fact, some of the biggest, most fundamental questions about these numbers are still complete and total mysteries.
Take, for example, Goldbach's conjecture. This idea is from way back in 1742, and it's super easy to understand. It says that every even number greater than 2 is the sum of two primes. For example, 10 is 7 plus 3, 20 is 13 plus 7. Here's the thing, mathematicians have tested this on computers for quintillions of numbers, and it has never once failed. But has anyone ever been able to prove that it's always true for every even number? Nope, not yet.
And that really leaves us with one final thought. We've gone from a simple, ancient sieve to the very foundation of modern digital security, all because of these special numbers. It makes you wonder, right? If something as basic as a prime number can hold so much power and so much mystery, what other incredible secrets are still out there, just hiding in plain sight in the world of numbers?